Welcome to our expert training video. In this comprehensive module, we will identify and describe the core architecture and components of Prisma Access, with a specific focus on the vital role of compute locations. Let's get started by establishing the foundation of this powerful cloud security service. Welcome to this training video on Prisma Access architecture and its components. We start with the core concept. What is Prisma Access? Prisma Access is defined as a Security Service Edge, or SSE, solution, delivered entirely by Palo Alto Networks from the cloud. This is much more than a simple firewall. It provides powerful, next-generation security capabilities such as secure web gateway functionality, advanced filtering for web links, and strong defenses against threats. The operational side is completely managed by Palo Alto Networks, meaning customers do not have to handle the underlying security infrastructure, making it always available and up-to-date. Prisma Access is essentially the core security part of the larger Secure Access Service Edge, or SASE, architectural framework. SASE is a modern concept that merges network functions, like connecting users and sites, with key security services directly in the cloud. This cloud-native approach ensures secure access for users and remote sites to the internet and applications, regardless of their location. By managing the security infrastructure itself, Palo Alto Networks ensures the service is resilient and secure, allowing organizations to focus purely on configuring policies and managing user access. Understanding Prisma Access means recognizing its role as a powerful, cloud-delivered security service within the SASE model. This foundational understanding sets the stage for examining its physical and logical components. What did we learn? Prisma Access is a comprehensive, cloud-native SSE solution that centralizes security management. This diagram shows how Prisma Access fits into the Secure Access Service Edge, or SASE, architecture. The SASE framework combines two main pillars: SD-WAN, which handles the network connections, and Security as a Service, which provides the protection. Prisma Access is the central platform that delivers this integrated security. It includes key security functions like Firewall as a Service, known as FWaaS, Secure Web Gateway, or SWG, Cloud Access Security Broker, or CASB, and Zero Trust Network Access, or ZTNA. These individual security capabilities are unified within the single, cloud-native service of Prisma Access, making management consistent and straightforward. This integrated approach is crucial because modern network security requires combining both networking and security functions seamlessly. Now that we understand what Prisma Access is, let's look at how it is controlled. There are two main methods for managing the configuration of Prisma Access: using Panorama or using the Strata Cloud Manager. Strata Cloud Manager, or SCM, is the modern central management portal, particularly favored for new deployments, as it integrates seamlessly with other services and simplifies the initial setup process. If you use SCM, it acts as a single point of glass for various security operations, including managing next-generation firewalls, SD-WAN, and all aspects of Prisma Access. Crucially, Prisma Access operates under a shared ownership model. Palo Alto Networks is responsible for managing the actual underlying cloud security infrastructure, including provisioning the required compute resources, monitoring the service status, and executing releases and upgrades. Your responsibility as the customer involves onboarding your specific locations and users, defining and pushing your security policies, and performing necessary log analysis and reporting. SCM is especially important because it centralizes settings like user authentication and agent configurations. What did we learn? Prisma Access operates on a shared responsibility model, managed via Panorama or the centralized Strata Cloud Manager. This flow diagram illustrates the shared ownership model for Prisma Access, which is key to its cloud architecture. The customer, represented as the user, uses either the Strata Cloud Manager or Panorama as the single point of configuration. This management console then interacts with the Prisma Access Cloud Service to define settings like security policies and user groups. The cloud service layer is where the actual infrastructure management happens. Palo Alto Networks takes care of the infrastructure provisioning and upgrades, ensuring the system is always ready and up to date. All activities and traffic data processed by the service are then directed to the Strata Logging Service for centralized log analysis and forensics, a task managed by the customer. This clear separation of duties simplifies operations for the user, as the complexity of maintaining the underlying cloud resources is handled entirely by the vendor. This architecture allows the administrator to focus purely on security policy outcomes. Following management, let's explore the data plane components, starting with how users in remote offices connect to Prisma Access. Prisma Access secures two main types of external entities: mobile users and remote networks. Mobile users, those accessing resources from anywhere, are primarily secured through two main methods: the Global Protect app or explicit proxy. The Global Protect app installs on the user's endpoint and creates an agent-based tunnel, ensuring consistent security for all their traffic, even when outside the corporate network. Explicit proxy deployments redirect web browser traffic to Prisma Access, commonly configured using proxy auto-configuration or PAC files for secure internet access. The second major component is the remote network, designed to secure branch offices or retail locations. Remote networks establish site-to-site connectivity using industry-standard IPsec tunnels between the customer premises equipment and Prisma Access. Importantly, remote networks consume a metered amount of bandwidth, which is allocated at the level of the compute location, not the individual branch site. This architecture allows organizations to quickly onboard and secure geographically dispersed offices. What did we learn? Prisma Access secures mobile users via Global Protect or explicit proxy, and remote networks via IPsec tunnels. This diagram shows the connection pathways for the primary data plane components. On the left, a mobile user endpoint connects via Global Protect or explicit proxy to a mobile user gateway within the Prisma Access cloud. Separately, a remote network, such as a branch office, connects using an IPsec tunnel to a remote network termination component. Both the mobile user gateway and the remote network termination funnel traffic into the security processing component inside Prisma Access. The security processing layer applies consistent, advanced threat prevention and inspection to all traffic flows, regardless of whether they originated from an individual user or a fixed site. The use of both agents and tunnels allows Prisma Access to protect diverse environments effectively. This unified processing is critical because it means that all types of users and sites receive the same level of protection delivered consistently from the cloud infrastructure. This ensures that the organization maintains a strong and consistent security posture everywhere. The third critical architectural component is the service connection, or SC, which builds on the connectivity methods we just covered. Service connections are IPsec tunnels, created specifically to link Prisma Access to your organization's internal resources, such as your corporate headquarters or data centers. These are vital when your mobile users or remote branch offices need to securely access private applications or internal infrastructure hosted centrally. Generally, service connections are used for internal traffic flows and are not intended for traffic egressing directly to the public internet, though traffic steering can modify this. A modern and streamlined alternative for accessing private applications is the ZTNA connector. This component simplifies the process significantly by automatically establishing secure tunnels to your private apps, removing the need for manually setting up complex IPsec tunnels and routing to data centers. ZTNA connectors also provide high bandwidth access, scaling up to 2 gigabits per second per connector. This functionality ensures that private IP addresses of applications are not exposed, enhancing security, and access is explicitly allowed based on policy rules. What did we learn? Service connections provide secured access to internal HQ/data center resources, while ZTNA connectors automate secure private app access. This diagram demonstrates how service connections and ZTNA connectors enable access to internal corporate resources. The Prisma Access Cloud contains the Central Service Connection Gateway, SCGW, which is the focal point for communication between remote components and the data center. Both mobile users and remote networks route traffic through the SCGW when accessing internal resources. The SCGW uses a traditional IPsec tunnel to connect to the physical HQ or data center. Alternatively, for access to private applications, the SCGW can leverage the ZTNA Connector Virtual Machine, ZTNAC, which sets up an automated secure tunnel directly to the private application. This ZTNA path ensures the application's private IP remains hidden and simplifies deployment. The Service Connection Gateway acts as the bridge, ensuring traffic destined for internal locations is securely channeled, allowing seamless and policy-enforced access for all protected users and sites. This dual approach ensures both site-to-site connectivity and flexible, zero-trust access to critical applications. The global reach of Prisma Access is one of its major strengths, offering a local experience in over 100 locations worldwide. To manage this scale and ensure efficient resource allocation, Prisma Access uses a concept called compute locations. A Prisma Access location is simply a physical point of presence where users connect, ensuring their experience is tailored to their locale. Crucially, every single Prisma Access location is mapped to a larger security compute location or region. A compute location is essentially a logical grouping of 2 or more geographically close Prisma Access locations. This grouping is done automatically to ensure optimal performance and low latency. For remote networks, bandwidth allocation is handled at this higher compute location level, rather than individual sites. This aggregate model allows Prisma Access to dynamically distribute bandwidth within that location group, based on the network load or demand, increasing resilience and flexibility. Local zones are a special type of compute location, placing computing services close to large population and industry centers, such as Lima, Peru, or Lagos, Nigeria. What did we learn? Prisma Access locations are grouped into compute locations for optimized performance, latency, and efficient bandwidth management. This conceptual diagram clarifies the relationship between Prisma Access locations and their associated compute locations. we see three main groupings: compute location A, B, and C, representing different global regions like the US West, Europe Central, and Asia South. Inside each compute location, there are multiple, geographically near Prisma access locations, shown here as L1A and L1B, and so on. For example, US West, compute location A, might group locations like Portland and US Northwest. The key takeaway is that traffic entering any of the individual locations within that group is processed within the resources dedicated to that compute location. This mapping is strategically designed by Palo Alto Networks for optimized performance and low latency for the end user. When configuring remote networks, bandwidth capacity is set for the entire compute location, allowing dynamic sharing among all connected sites within that group. This organizational structure is fundamental to Prisma Access scalability and efficiency across its massive global footprint. When planning a Prisma Access deployment, resource allocation is heavily tied to the compute location concept. For remote networks, bandwidth is allocated in aggregate at the compute location level. This means if a compute location has 200 megabits per second allocated, that capacity is shared dynamically among all the branch offices connected to it, based on current load and demand. This is a flexible model, ensuring that bandwidth can be dynamically reallocated as needed. For remote networks designed for high performance, Prisma Access simplifies endpoint configuration by typically providing a single IP address, or fully qualified domain name, FQDN, as the service endpoint address for every 3 gigabits per second of bandwidth allocated in that compute location. To ensure business continuity, redundancy is crucial. Prisma Access supports location redundancy, where you select a primary compute location and an optional secondary compute location placed in a separate region for backup. Additionally, IPsec tunnel redundancy can be set up in an active/passive or active/active configuration to provide failover protection. What did we learn? Bandwidth is allocated centrally by compute location, and redundancy involves selecting primary and secondary compute locations or configuring IPsec tunnel failover. This pie chart visually represents the dynamic bandwidth allocation model utilized for remote networks within a single compute location. Instead of dedicating fixed bandwidth to individual sites, the total capacity of the compute location is pooled. We see here that sites connected to location 1 are currently using 30% of the total available bandwidth, while sites in location 2 are utilizing 40%. The remaining 30% is shown as reserve capacity, which can be dynamically allocated to any site within this compute location as demand increases. This aggregate bandwidth model provides flexibility and optimizes resource utilization across geographically nearby sites. This capability allows Prisma Access to handle fluctuations in network traffic effectively, without manual intervention, automatically allocating resources based on the site's actual load or demand. This is a core feature that enhances the resiliency and performance for all connected remote network sites. The overall architecture of Prisma Access is significantly enhanced by integrated services that ensure visibility and flexibility. Firstly, logging is centralized. All Prisma Access activity, including traffic, threat, and configuration logs, is automatically stored in the Strata logging service. This centralized approach is crucial for comprehensive analysis, generating reports, and performing forensic investigations across all sites and mobile users. Secondly, for superior monitoring, the architecture includes Autonomous Digital Experience Management, or ADEM. ADEM is natively integrated into the infrastructure and provides crucial end-to-end visibility and performance metrics for all user traffic within the SASE environment, helping quickly pinpoint and fix digital experience problems. Lastly, for advanced security operations, a feature called traffic replication enables continuous copying of traffic data in PCAP file format. These files are securely stored in managed storage buckets and are used by analysts for forensic analysis or proactive threat hunting. This combination of logging, visibility, and optional traffic copying provides operational depth and support for various connectivity methods, including agent-based, agentless, explicit proxy, and site-to-site tunnels. What did we learn? Strata logging service centralizes data. ADEM provides crucial experience visibility, and traffic replication enables deep forensic analysis. This diagram highlights the critical support services integrated into the Prisma Access architecture, moving beyond basic connectivity. User and site traffic flows into the main Prisma Access cloud, where security inspection occurs. From there, the traffic metadata is immediately sent to the Strata logging service for central storage and forensic analysis. Separately, the entire network experience is constantly monitored by Autonomous Digital Experience Management, or ADEM, which provides deep insights into performance and user experience. For specialized security needs, the system also supports traffic replication, which creates copies of the raw traffic, stored as PCAP files in secure buckets, enabling deep forensic analysis and retrospective threat hunting. The arrows show that while PA is the central processing unit, the specialized services provide the necessary visibility and data retention required for sophisticated modern security operations. we have covered the end-to-end architecture of Prisma Access, from high-level positioning to specific components. Prisma Access is the leading Secure Access Service Edge, or SASE, solution, delivering security services globally. Management is simplified through a shared model where Palo Alto Networks handles the underlying cloud infrastructure, while administrators use the Strata Cloud Manager or Panorama for policy control. The data plane supports mobile users through Global Protect and Explicit Proxy, and fixed sites through remote networks using IPsec tunnels. Connectivity to internal applications is ensured through service connections to data centers, or the automated ZTNA connector. Crucially, the global footprint is organized around compute locations, which group geographically close physical locations together for optimal performance, and where bandwidth allocation is managed. All operational data flows into the Strata logging service for mandatory storage, complemented by the autonomous digital experience management service for real-time visibility. Ultimately, the architecture is designed to be cloud-native, offering built-in scalability and resilience, eliminating the burden of managing hardware or software upgrades for the customer. This unified platform is the core of modern, distributed enterprise security. What did we learn? Prisma Access architecture combines cloud-native management, diverse connectivity methods, global compute locations, and integrated visibility services for comprehensive SASE delivery. This comprehensive diagram summarizes the Prisma Access architecture by showing the key relationships we have discussed across the previous slides. At the top, the Strata Cloud Manager or Panorama acts as the central management point, pushing configurations down. These policies govern the global fabric, which is structured around compute locations, which then contain the physical Prisma Access locations. These locations host the data plane components, which handle the live traffic. These components include mobile users, remote networks, and internal service connections, or ZTNA. All process traffic and operational data generated by the data plane components flow directly into the Strata logging service and ATOM for centralized monitoring and analysis. This unified view emphasizes that all parts of the deployment, regardless of location or connection type, are governed by a single, integrated cloud architecture.